In this video, we're talking about the extreme value theorem, which basically states that for any continuous function over a closed interval, the function has an absolute minima and an absolute maxima. And we denote the minima with a lowercase m, maxima with an uppercase m. Let's take a look, an example using this. So we've got this example, h of x is x e to the minus x over the interval 0 to 3. Now, one thing you always have to remember to do when you're talking about absolute minima and maxima over a closed interval or over an open interval as well is you have to check the endpoints. And in this case, h of 0 is 0 onto e to the minus 0 is just 0. Right? So we know at 0, x equals 0, h is 0. We know this function based on its form is positive over the range 0 to 3. So we already have an absolute minima. And if we look at h of 3 times e to the minus 3, what does that equal? Well, I'm going to pop over to Excel, and this equals 3 times e to the minus 3 is 0.149. 0.149, which is larger than 0, right? And so next, what are we looking for? We're looking for critical values. What is a critical value, right? Critical value is where the derivative equals 0, right? So let me denote this as a critical value. So critical values are where the derivative is 0. What is the derivative of this function? So the first term is x, so 1 c dot e to the minus x plus minus x plus x onto minus e to the minus x. So I can factor out the e to the minus x, and that's onto 1 minus x. Now, where does this equal 0? So we know we have a critical value at x equals 1, right? That's going to equal 0 at x equals 1. So this is most likely a maxima, right? But to know definitively whether or not that it's a maxima, let's take the second derivative. Is, okay, first term, minus e to the minus x onto 1 minus x plus e to the minus x, and the derivative of the second term is just minus 1, right? So factoring out the e to the minus, or minus e to the minus x onto, this will be 2 minus x. So this is the second derivative. At the critical value of 1, it is negative, all right? So 2 minus 1, or 2 minus 1 is just 1 onto minus e to the minus x. And so it is concave down at that point. And so we know that is a maxima, that we have a maxima at x equals 1. What is the value at x equals 1? So at 1, it is 1 times e to the minus 1, which is 0.368, right? Which is greater than the endpoint value. That all makes sense. And so we know we have two things now. We have the location of the minima is at 0 and there h of x of m is 0, and we know the location of the maxima is at 1, and h of x at the maxima is 0.368. And that covers this function. All right, so what did we do? We evaluated the endpoints. We took the first derivative to find the critical value. We found the critical value. We checked to see that the derivative, the second derivative, was negative or positive on both sides, and it is. You can see that there is a point, an inflection point, or a point where the second derivative changes from negative to positive at s equal 2. That's in this range, but the only 0 in this range in the first derivative is at 1. And so we have the minima, the absolute minimum, we have the absolute maxima of this function over the range 0 to 3.